Hello there, this is 7.1.2, the video for this lesson. Warn you ahead of time, just thinking about all the back and forths and how this will work. This will probably be a little bit longer video, and I apologize for that. So 7.1.2 is comparing rates with tables and graphs. I mean, that's really the key part. So how can we compare these? We're going to use tables, we're going to use graphs to do some of this comparison. So rates are used in many different situations to describe and compare information. For example, you might compare the gas mileage of different vehicles when you're buying a car. Gas mileage refers to how many miles each car can travel per gallon of gas. You may want to determine the print quality of a paper by comparing different printers' numbers of dots per square inch. In banking, the percent of interest comes in interest earned per dollar, called the interest rate, is an important rate to consider. So today we're going to focus on using these tables and graphs to, and then think what we'll start with first is some racing data. So the local news station is selecting the week's student for Athlete of the Week. Wendy and Yoshi, sprinters on the track team, are both finalists. They're trying to decide who's the fastest based on the recent race data. Wendy's times are represented in the table, not at right, but on this resource page. Complete the table for Wendy, and then how can we use that table to find Wendy's running rate? Ooh, that would be a hard one to say many times. How can you write her rate as a ratio? Okay, so let's go over there and let's take a look. There it is. There's Wendy's information, and what we're going to do is finish filling this in. And if we notice that in 5 seconds she goes 30 meters, so then in 10 seconds she would go, what, 60 meters. Then, as we follow this, it goes 5, 10, 15, and then you might think that it would be 120, but that would be wrong because it's not increasing by 5 again. This time it increased another 10. So 2 5s would be 60, right? 2 5s for 10 more seconds would be 60 meters. So 60 plus the 150 or plus 90 would be 150 meters for that one. So we'll keep moving through. Another 10 would be 60 more meters. So from 35 to 45 would be another 60 meters. So that would be 270. Okay, so there we go. We finished filling out hers there. And we'll move on. We'll answer the rest of those questions in this one, right? So here we go. So we completed the table. How can you use the table to find Wendy's running rate? How can you write her rate as a ratio? Well, let's go back one more time. And I see you could just say, hey, for every 5 seconds she does 30, or she runs 30 meters, right? So a ratio could be seconds to meters. And you could choose any number you want in there. But I could choose 5 seconds to 30 meters. You could have chose the 10 seconds for 60 or whatever it happened to be. Your choice. Okay. So what we're doing is by using that table, we are, how do we find that? We find that by grabbing those ratios, the seconds in meters, right? Yoshi can run 7 meters in 11 seconds, which can be expressed by the ratio 70 meters to 11 seconds. So they did meters to seconds. So if I were to switch this would have been 30 meters. Whoops, let me fix that here. Just so it looks the same, 30 meters for 11 seconds. So that looks, not 11 seconds, 5 seconds. So you notice it's meters to seconds, just like Yoshi's. Do the two runners travel at the same speed? If not, who's running faster? Well, let's look back here at 11 seconds and see. Wait, was it 11? Yeah, it was 11. Oh, I don't have that. So we're not 100% sure. Since he runs 70 meters in 11 seconds, let's take a look and let's see what Wendy did. At 10 seconds, she did 60. Hard to tell, isn't it? So I'm sorry it's back and forth. I know you can pause and go back to the video. So pause and stop and read or whatever, which can be expressed as a ratio of 70 to 11. Do the two runners travel at the same speed? Not sure. Not sure yet, right? If not, who's running faster? I think, based on what it seems like Yoshi is running faster because Wendy, right? Wendy does 60 meters in 10 seconds. And it seems like that would be the case, right? So, Yoshi, explain your reasoning, right? To compare the two runners, the news station wanted to make a graph. Whoops. Why did we... Oh. Okay, so there we go. So what we're going to do is we are going to compare the two by graphing their rates, right? So we're going to graph that, but we can make a table and we're going to complete that. And that's really the key part that's going to help us here, right? So if we find out that he does 11 seconds in 70 meters, what we could do is we can just keep building this up. On 210, nothing yet that we can, we can actually compare here, right? It looks like it takes Yoshi less time to do 210 meters, doesn't it? 44 and 280, and then, there's a 55. That would be kind of nice. Bump right there would be 350. There we go. There's a nice, easy way to do that too. In 55 seconds, who does more, right? Yoshi does. So now let's graph that. So we're going to graph that right down below here, and it's going to be a little hard to do because I got to bounce back and forth. If Wendy does, I'm going to do Wendy, we're going to choose a different color for Wendy. Let's do a red here. So let's do red part is Wendy. And she does 5 seconds, 30 meters, right? So what we're going to do is we're going to go down here to 5 seconds, which is right here. And we're going to do 30 meters. 30 meters is about... Let's go with about here, right? Because each one of these, this has to be 25, 0, 25, 50. So that's that. We'll put that one right there. And then what I'm going to do is I'm going to grab her 55 and 330 mark. So let's go to 55. We're going to follow it up to 330. So that's going to be a little hard for us to see both of these. So there's the 55. And let's do the 330. And it's right there. And what I'm going to do now is I'm going to grab the ruler. And I'm going to line these up. See that? I line those two dots up. And there we go. There's Wendy's, right? Now let's do the same thing for Yoshi. Yoshi is at 11 seconds, 70. So for Yoshi, let's do this blue. Yoshi. Did I spell that right? Yep. 11 seconds, 70 meters. So this one's going to be a little hard because 11 seconds is going to be somewhere right here. 11 seconds, 70. This is 75. So it's going to be just below that. So 70 and 11 seconds will be somewhere right around there. It's going to be a little hard to see. And then what else do we know? That he, at 55 seconds, 350. Oh, that'll be a little easier for us to do. So at 55 seconds, 350 will be right there. And what we'll do is we'll put that ruler on for Yoshi. It's kind of trying to snap to this, and I think we're doing okay. It didn't snap too hard, but there we go. There's Yoshi's in blue. All right. What does this show us? It does show us that Yoshi is faster than Wendy, right? A little bit faster with that blue there, and we just have to be really accurate to see that sort of thing, right? So, created a table. We did that, and then work with your team to decide how to set up the table and complete it. We kind of did that, right? And then using the coordinate grid, we plotted the pairs. Whoops, I kind of jumped ahead, and we used showed that, right? I showed that on the graph. And for both also, right? Based on the graph, who's running faster? Does this match your conclusion? Yeah. Well, Yoshi, right? Yoshi's faster. We could see that because Yoshi's just a little bit ahead of Wendy. Does it match the conclusion? Yes, it does. What's the justification? The line for Yoshi, line for Yoshi is steeper, really, right? Isn't it a little bit steeper than Wendy's? A little bit steeper, right? The graph on 7.1.2 resource page shows information for Vanessa, last week's athlete of the week. What is Vanessa's rate? If she were to race Yoshi and Wendy, who would win? What's her rate? All right. Well, let's go to Vanessa and let's take a look at kind of what she did. It looks like, it's hard to tell how she did. It looks like she did here, if we jump up, and I can't see that 55, can I? I can't see that 55, but maybe there's a number that would help me get a little bit closer. Let's see if we look at 10 seconds, right? At 10 seconds right here, and we go up, it looks like, what did she do? She did 50 meters. So if I compare that, right? If I compare that to Wendy, who's faster? It looks like Wendy's faster. So if Wendy's faster than Vanessa, then what can we say about Yoshi? Yoshi is also faster, right? So Vanessa, although did really well, is not quite as fast as those two. So let's go back down here. What is Vanessa's rate? She goes 50 meters, wasn't it? 50 meters in 10 seconds. 10 seconds. If she were to race them, who would win? Yoshi would win. It looks like there's an E there, would win. So maybe I have that wrong. It's Yoshi without IE. I could have misspelled that a couple times. All right. Training for the triathlon. A triathlon race is in which participants swim, bike. Let me go back. I'm sorry to this graph. I just want to make sure it's clear. So when we look at this rate, right, we want to try to do the best we can to have the same sort of seconds, right? So when I look at something like this one, it made it easy to do, like in this case, seconds, 55 seconds. Or if we had the same distance, notice that distance and that distance were the same, but notice it took Yoshi less time. Now on here, the only thing that made it easy on here was the fact that we would be able to compare, these numbers showed up nicer on the graph for Vanessa. Not Yoshi's data, right? Yoshi's data wasn't quite as nice as Wendy. And so because of that, it made it a little bit more difficult to compare what we needed to do on there. But if we followed, if we compared that stuff from Vanessa to Wendy, made it a little easier to do. In fact, if we were to graph, let's do a purple for Vanessa, 10 seconds, 5, right? Or 50, hers would be right here. And then let me choose one more. Looks like if I follow the 50, she would be at 250, right up here. So 50 and 250 right here. You can see then that her graph wouldn't be quite as, it wants to snap back and I don't like it snapping here. Yeah, you can see there when Vanessa's would be a little bit slower. Okay. All right, we got to move into this one. All right. So we have a triathlon. That means that you have 3 things to do for a particular race. You swim, bike, and run. Participants start by swimming. After swimming, they jump out of the water, get dressed as fast as they can, and ride a bicycle. After they complete the biking section, the participants finish the race by running several miles. Diane's preparing for her first triathlon. She used the graph, which I'll show you in a moment, to analyze one of her practice sessions. Use that graph to help answer these questions. During that segment of the race, A, B, or C, did Diane go the fastest? Explain your reasoning. Explore using the graph at the right, or that is on the other page. During this, which segment of the race, A, B, or C, did Diane go the fastest? Explain. Okay, well, let's go to that graph, and let's process what's going on in here. This is the original graph that's shared with you. And how do you go, what's that fastest, right? Well, first you swim, then you bike, then you run. I think it makes sense that you would go faster as a biking part than as a running or swimming part, right? And this one was the bike. It's running and that's swimming. And I think we would probably agree, just from past experiences in life, that biking would be faster than running and running would be faster than swimming. But how do we know that that's fastest, right? Well, because this right here is the steepest. Because we are going, if you think about it, we go the furthest distance, miles. Let's just, even if you guessed, right? Let's say it's 13 miles. It's not quite that or whatever, right? Maybe it's just a guess of about 13 miles in. If we follow that, that would be 18 minutes down, and we would maybe here. What we would find is that rate is you accomplish more distance in the shorter amount of time, right? More distance than a shorter amount of time in that steepest part. And because Diane's swimming is really low, right? Really, really flat. That would mean that it's slower, okay? All right, so now we have some real data right here to actually use and to help us find that, right? So here we go. Let's go back to answering those questions. During which segment of the race did Diane go fastest? I think it's pretty obvious that it would have to be during the bike. Explain, right? That was that steepest graph, right? Which use a graph to determine the distance traveled during each segment of the race. Okay, so let's find the distance traveled for each of the 3 spots. Then, how much time did it take to complete those? So I'm going to accomplish B and C, and then write a rate in miles per minute, miles per 1 minute for that. So we'll get that all figured out as we go. Okay, going back to the graph, let's find out how many. What's the distance traveled, right? So let's go swimming. Let's go with blue because that makes the most sense, right? And it looks like, what did Diane do? It looked like Diane went from 0 miles, right, up to a half a mile. I think that's, yep, distance in miles, right? So she went 0.5 miles. So while I'm zoomed in, let's see how long did it take. No, this was in minutes, right? So let's find out. It was from 0 minutes to 18 minutes. So she did 18 minutes for swimming. All right. So we got that swimming. Let's do the biking. Biking seems like a green. I don't know why. Now, what happened during the biking time? The biking time went from 0.5 miles to, looks like 12.5, isn't it? Well, how many miles was that? That was 12 miles, right? 12 miles if we subtract the half mile from the 12. And then let's find out the time, or I'm just trying to line this up when we zoom in. So it looks like it went from 18 to 60, right? So how many minutes would that be? 60 minus 18, all right, would be 42. 42 minutes. Whoops, not miles, minutes. Okay. Did I do that right? Something feels wrong. Mm-hmm. 12. 60 take away 18, right? 60 would take away 18, 42. Yeah, I think I'm right here. Okay. And then for her running, because she's really tired, we'll use red. I don't know why. Here we go. We follow that over. That's 12.5 miles, right, to right over here, which is 15.5 miles. So 15.5, that means that she did 3 miles, right? And then let's figure out our time. We follow that down again, right? What is that? That's at 60 seconds all the way down, or 60 minutes, sorry, down to, what would that be, 93? Did I have that line right? Yes, I did. 93, that's an odd number, huh? So how many minutes did that take? That took 33 minutes. Whoops, why did I put it down there? There we go. All right, so let's put all that information there. That's a half mile in 18 minutes. Half a mile in segment A. Distance, half a mile and that was in 18 minutes. Okay. Let's go back. Let's grab the information from the other one. 12 miles in 42 minutes. 12 miles, 42 minutes. 12 miles in 42 minutes. And let's go back to the last part. 3 miles in 33 minutes. 3 miles in 33 minutes. 3 miles in 33 minutes. All right, right, in miles per minute. So how many miles did they do in 1 minute? That's what that per minute means, right? Oh, well, we could double that. That's 36 miles per minute. Okay, 36 miles per minute. Let's look at what we did here, right? How many miles per minute here? Wait a second, did I? Man, something isn't. 12 miles, 42 minutes. Oh, that's because I calculated this one wrong. That's not 36 miles per minute. That's 36 minutes per mile. I was like, wow, that is flying. There we go. Let's get that right. In 1 minute. So I really have to take that 0.5 miles and divide it by 18. 0.5 miles and divide it by, whoops, I don't need the miles in here. Divide it by 18. In this case, let's just use a calculator, right, to do this. So we're doing 0.5 divided by 18. And I'm going to do that for us here. 0.5 divided by 18. I could use an add. 0.5 divided. Oh, you're kidding me. Divided by 18. And what do we get? 0.27 miles per minute. So 0.027. 0.027. 0.027 repeating miles per minute, per 1 minute. All right, let's do that same thing for this one. We did 12 miles in 42 minutes, so we got to take 12 divided by 42. 12 divided by 42. 2.285. 0.285. We'll have to round that. Let's just round that to 0.29. Not 0.285. Round that. 2.8, and we'll have that. We'd have 5 7, so we'll make it that 7, so that we did the 3 digits there, and we did 3 digits here for 1 minute. And then for segment C, we have 3 miles and 33 minutes with an extra hump in that M. That's really weird. So 3 divided by 33. 3 divided by 33. 0.090. Oops, probably could have changed that color. It's 0.00909 would make that, we round that to 1 miles per minute. There we go. All right. Make that blue. Okay. So now we can see who's the fastest, right? Now we can see who's the fastest by just saying how many miles were accomplished in each minute. Looks like the green did more, right? All right, let's do this last one. Match each situation in part A through D with its graph from 712 and state the rate. Family A travels 30 miles in 25 minutes. 30 miles, 25 minutes. Whoops. 30 miles in 25 minutes. Let's find that here. Which one did 35 30 miles in 25 minutes. Looks like maybe C did, right? Because if we look at it here, here's the 30 miles. Oops, that's 20 minutes, isn't it? So that's not quite right. I see the 30 miles here, and it looks like it'd be between 20 and 30, so graph 4, right? Graph 4 would be our first one. 4. Travels 60 miles in an hour. So let's go back to our graph. 60 miles in 1 hour. 60 miles in 1 hour. So we need to have, as we look at them, it looks like 60 miles would be accomplished in 60 minutes here. So that would be graph 5. Graph 5. Family C travels 50 miles in 1 hour. 50 miles in 1 hour. 50 miles in 1 hour. So we know it's not 4 or 5. So let's look at these. 50 miles in 1 hour. Looks like we would be graph 1, 50 miles in 1 hour. So that's graph 1. So we have that one done. And family D travels 60 miles in 1.5 hours. Woo, that one I feel like would be making it a little tricky because 1.5 hours does not fit. So 60 miles in 1.5 hours. So it's got to be between these two, right? And if we think about it, 1.5 hours would be 90 minutes. So so let me see if that would work. 30 plus, now this is 20, right? 10, 20, 30. So then at 60, we are at 40. At another 30 minutes, right? So at 90 minutes, we would have to do another 20. So we would do 60 miles. That would have to be graph 2. Graph 2 would have that. Okay. What's the rate? We do want to keep them all the same. Ratio of we could write that ratio of miles to minutes. Miles to minutes. Miles, we could say, is 30 miles in 25 minutes. This would be 60 miles in 60 miles in 60 minutes. This would be 50 miles in 60 minutes, and then we would have to do 60 miles in 90 minutes. We have to make sure we put it all in the same. One graph below was not matched. If family E is represented by the unmatched graph, describe the rate of travel for family E. Let's go back here. Let's describe what this one would be. All right, that one would be, how could we rate that one? I have those 2 green dots. Looks like they do 30 miles in 20 minutes. 30 miles in 20 minutes. Last one. 30 miles in 20 minutes. There we go. If you have any other questions, please let me know. Have a good day.